Our learning intention, you can create a model to test ideas and meet criteria within constraints. The success criteria, you can design a paper bridge to test how much load it can hold. On a Flipgrid, you can tell how your design met the criteria and tell how your design worked within constraints. Your materials that you will need between 1 and 3 pieces of paper. The paper must be regular printer size paper or worksheet type paper. That size is 8.5 by 11. If you're using notebook paper, that's about the size that it will be. You will need your baggie of beans. That's the baggie from your baggie that you received in back to school night. If you don't have these, use something equivalent. You can possibly use maybe some pennies. If you maybe have a jar of coins, just pull out the pennies. The baggies, don't throw those away. The baggie of beans, don't throw those away because we'll use them in another design challenge. You'll also need 2 stacks of books or something equivalent, maybe 2 boxes. Make sure they're about the same size. Your challenge details. Criteria. Your criteria is you will design a paper bridge which can hold the most beans, that it can build one that will hold as many beans as you can, or equivalent. Maybe you're using pennies. Your bridge must be made out of paper. Also, your bridge must span the gap between 2 stacks of books. The stacks of books will be about 8 inches or 20 centimeters away from each other. Your constraints, you cannot use more than 3 pieces of paper in your bridge design. The gap between the stacks of books cannot be smaller than 8 inches or 20 centimeters. They can't be closer together. They have to be 8 inches. Your Flipgrid is due by the end of your second asynchronous day at 4 p.m.
Do you think that by just using 1 piece of paper, we can make a bridge that holds a lot of pennies? To make our paper bridge, we're allowed to fold or bend the paper. There also has to be 2 piles of books at least 8 inches apart that the bridge has to go on.
Okay. We can just try 1 piece of paper and like
a penny.
1 penny.
See if it holds it. Oh, no. Okay, that works.
That doesn't hold 1 penny then. Well, maybe we should like fold it somehow.
What if we fold the paper in half? So
the long way.
Yeah, so we can layer it. Something?
Yeah, that's a good idea. So like this.
So you want to try that?
We can just try that.
Okay.
I'll put 1 penny.
Make sure you spread.
Hey!
Oh, it works.
It holds 1 penny.
So let's keep putting them on. 2,
3,
4, 11,
12.
Uh-oh.
It held 12 pennies. But I thought that method works pretty good. Maybe if we fold it one more. Do you want to try it just folding it one more time?
Okay. Hold on.
1,
2,
3,
6,
7.
Uh-oh, it looks like it's sagging. No, it's gonna fall.
8.
So here's some civil engineering vocabulary. Failure is when the bridge or structure could no longer hold the weight of the beams or the load that it's carrying, and the bridge collapses or breaks and it can no longer be used. There's a picture to the right. Failure, sometimes we think of failure at school is when you don't pass a test or something like that. In engineering, it's when the structure cannot be used. It fails, it breaks. The load is the weight that a bridge is holding or supporting. So if a truck is driving across a bridge, that's the load that it's holding. The beams will represent your load this time. Flipgrid. This Flipgrid link will be inside of Schoology. In your video, show us what you designed. Also, say how much load your bridge was able to hold before it failed. Where did you have success? You're also going to talk about your criteria and your constraints. It'll be right there in Flipgrid for you to see.